Hello my friends and welcome back to the Today Machine channel. This scrap metal shredder is a powerful machine designed to reduce the size of various types of metal scraps, making recycling more efficient. The shredders can handle materials like mild steel, stainless steel, aluminum, copper, and even electronic waste. With a capacity ranging from 1,000 kilograms to 8 tons per hour, they are used in both domestic and industrial metal recycling processes worldwide. The shredding process starts by feeding scrap metal into the shredder. The machine's rotating blades break down the large metal pieces into smaller, manageable sizes. This size reduction helps improve transportation efficiency, as shredded metal takes up less space and is easier to handle. Additionally, shredding helps separate and recover valuable metals, such as silver, gold, and platinum, which are often found in electronics. The control systems of these shredders can be automated or manually operated, depending on the machine's design. After shredding, the small metal particles are ready for recycling and can be transported easily due to their compact size, lowering costs. Shredded metal is also advantageous for remelting processes in furnaces, as it improves furnace efficiency and reduces smoke emissions. By eliminating contaminants and refining the quality of the metal, the shredding process increases the overall value of the recycled material. A key benefit of using heavy-duty industrial shredders like those from Max in India is that they are maintenance-free, noise-free, and vibration-free, ensuring a more efficient and eco-friendly recycling process. Saarstahl Askoval is an electric steel mill that produces green steel by melting scrap metal in an electric arc furnace and continuously casting it into billets, blooms, or rounds. The first step in the production process is the correct composition of raw materials. Different types of scrap steel, each with its own characteristics, are loaded into scrap bins and transported to the furnace using a crane. The electric arc furnace has a capacity of 90 tons and operates with a power rating of 115 MVA. The steel scrap is melted into liquid steel at a temperature of 1,650 degrees Celsius, achieved through 3 powerful graphite electrodes that generate the arc for melting. Throughout the melting process, samples of the molten metal are regularly taken and analyzed in a laboratory to ensure the desired steel quality. Adjustments to the composition can be made at this stage to meet specific client requirements. Once the steel is fully melted, it is transferred into a ladle, which is then moved by an overhead crane to the ladle furnace. Here, further refining takes place by adding alloying elements to tailor the steel to customer specifications. The temperature is precisely controlled and homogenized using an electric arc to ensure consistent quality. For high-quality steel grades, additional refinement is conducted in the ladle furnace before the molten steel is transferred to the continuous casting plant. The casting process begins in the casting tower, where the liquid steel is continuously poured into molds to form billets, blooms, or rounds. The casting machine operates at speeds of up to 80 meters per minute, producing rectangular billets and round blooms of various sizes. Once the casting is complete, the bars are cut to the customer's required length and transported to the cooling area. Integrated within the Saarstahl Group, this facility focuses on steel recycling, playing a vital role in the circular economy by using scrap steel to produce new steel. This eco-friendly approach highlights the importance of sustainability in steel production. After cooling, they are either shipped to customers or further processed on-site. If the customer requests, the cast bars can undergo additional processing in a forge. The bars are reheated to 1,250 degrees Celsius and transported to the forging press, where they are shaped according to specific dimensions. Durostal represents both tradition and progress in the art of forging. The company is one of the largest and most modern open die forging companies in Europe. The raw material is cut to the calculated weight using one of the 20 circular or band saws. This allows the workshop to cut raw material blocks, pre-forged long products like shafts and rods, with millimeter accuracy. These materials can be cut into dimensions of up to 1,800 millimeters in diameter, 15 meters in length, and 35 tons in weight. Forging process. At temperatures ranging from 550 to 1250 degrees Celsius, the raw material is heated and brought under the hammer. Forging, one of the oldest crafts known to humanity, remains the heart of the company's operations. Though the methods have advanced beyond manual hammering, the fundamental principles are still the same. Smaller parts, weighing between 10 to 2,500 kilograms, are forged on steam hammers weighing between 300 and 6,000 kilograms, as well as on hydraulic presses. The smallest components are still handled manually with tongs and levers, requiring great craftsmanship and coordination among the hammer crew. To ensure quality, all parts are stamped with a unique commission number, which guarantees traceability and identification throughout the production process. Larger forged pieces are handled using electro-hydraulic manipulators, which allow parts weighing up to 6 tons to be forged. This provides flexibility in terms of the shape and size of the forged components, whether for single pieces or series production. Hydraulic pressing. The workshop uses 2 hydraulic 4-column presses with an underground design and pressing power of up to 40,000 kilonewtons to forge components weighing up to 45 tons. Combined with rail and free-fall manipulators capable of handling up to 50 tons, these presses produce large components like axles and drive shafts in a single operation. The hydraulic presses work in tandem with electronic controls to optimize the forging process and ensure consistent quality. Ring rolling. Pre-forged hollow discs serve as the base material for seamless rolled rings, which are processed on two modern ring rolling machines to achieve their final dimensions. The combination of forging and rolling ensures optimal material properties, enhancing the structure and flow within the material. Computer-controlled process monitoring provides real-time data on the rolling path, volume, and quality of the rings, ensuring that they meet stringent dimensional and performance standards. These rings, with a diameter of up to 3,500 millimeters, a height of 850 millimeters, a wall thickness of 500 millimeters, and weighing up to 8 tons, are later used in the production of gears, bevel gears, sliding bearings, ball bearings, sealing rings, and much more. This process reduces material use, machining effort, and overall costs by producing rings within tight tolerances. Heat treatment. After hot forming, the forged components undergo a heat treatment process to achieve their optimal material properties. The heat treatment involves hardening temperatures of up to 950 degrees Celsius and tempering at temperatures of up to 750 degrees Celsius. The workshop utilizes 33 annealing furnaces equipped with the latest burner technology, which allows them to carry out cost-effective and environmentally friendly heat treatments, including hardening, tempering, normalizing, and solution annealing. These treatments are essential to enhancing the wear resistance, toughness, and flexibility of the forged components. Seamlessly integrated production facilities ensure that the rings undergo heat treatment immediately after forming, enabling energy-efficient and environmentally friendly operations. Machining. The company operates a 9,000 square meter mechanical workshop staffed by approximately 130 workers who perform precision machining according to customer specifications. The workshop is equipped with specialized centers for sawing and turning, including a roto-catter center for cutting and machining seamless rolled rings. Precision is achieved in processes such as turning, drilling, and milling, even for large components weighing up to 35 tons. For deep hole drilling operations, the workshop can achieve bore lengths of up to 4,200 millimeters. This extensive range of machining capabilities ensures that they can handle a wide variety of forged components, meeting exacting customer requirements. Quality control. The company has maintained an ISO 9001 certified quality management system since 1992. Quality control is an integral part of their operations, with over 4,700 standards and customer-specific regulations being adhered to. The forged parts undergo thorough testing, including automated ultrasonic testing for internal defects, tensile tests to measure strength and elongation, and impact testing to assess toughness. Additionally, chemical composition is analyzed in real time using spectrometers, ensuring the highest material quality. Automated inspection lines subject series produced parts to a range of tests, beginning with ultrasonic testing and including rigorous dimensional and hardness tests. These stringent quality control measures ensure that Die Rohstahl's forged components meet the highest standards of performance and reliability. The H6 horizontal machining center is designed for machining the toughest materials like Inconel and titanium. With a pallet size of 630 mm by 630 mm, it offers a powerful solution for heavy-duty cutting applications. Its X and Y axis feature twin drive systems with 2 ball screws and extra-wide box guideways for exceptional precision, stability, and high cutting rates. These design elements make it capable of handling the most demanding machining tasks while maintaining excellent accuracy. The Hermle C60 Dynamic 5-axis mill turn machining center is ideal for precision, high-performance tasks such as the machining of a fan disc with pine tree groove cutters from 1.2738 steel, commonly used in the energy industry. In this configuration, the machine offers simultaneous 5-axis machining capabilities, allowing for complex contouring and dynamic part manipulation, which is critical when cutting intricate geometries like pine tree grooves. Equipped with a working range of X equals 1,200 mm, Y equals 1,300 mm, and Z equals 900 mm, the C60 can handle large, heavy components up to 2,500 kg. Its main spindle achieves speeds up to 18,000 revolutions per minute, ensuring high material removal rates. The tool holding fixture combined with a 70-pocket tool magazine allows for quick tool changes, maintaining efficiency across long production runs. The machine's advanced control unit provides precise and flexible control, critical for high-end milling applications like fan disc production. The C60's swiveling rotary table enables simultaneous machining on multiple axes, providing access to hard-to-reach areas of complex parts. This 5-axis mill turn machine allows operator to meet the demands of high-precision, large part manufacturing with minimal operator intervention. The Hermle C60 machines operate efficiently in multi-shift setups, ensuring optimal capacity usage and ROI for energy sector clients. Hobbing is a precision machining process used to cut gears, splines, and sprockets. It involves the use of a specialized tool called a hob, a cylindrical cutting tool with helical teeth. During hobbing, the hob rotates continuously while meshing with the workpiece, which rotates on a parallel axis. This synchronized motion generates the gear teeth profile, making the process highly efficient and accurate for producing gears in large quantities. Gear cutting, on the other hand, refers to the broader methods for creating gear teeth, which include hobbing, shaping, broaching, and milling. Hobbing is particularly favored for producing spur, helical, and worm gears due to its speed and cost-effectiveness. The precision of gear cutting processes ensures the correct alignment, strength, and durability of gears, which are critical components in automotive, aerospace, and industrial machinery. High-quality gear cutting results in quieter operation, improved load distribution, and longer gear life. This video is about machining of wheel stub with Coro-turned prime twin tool holder. Modern multitask machines are intended for the complete machining of components but typically have a very slow tool changing time. The new Coro-turned prime twin tool saves operator time when changing tools to increase machining utilization and productivity. The operator can do roughing with a B-type insert and then switch to finishing with an A-type insert, all within the same tool and operation. This streamlined operation of the Coro Turn Prime Twin Tool Holder for multitask machines reduces inventory and increases productivity for a versatile, yet easy operation. The Coro Cut QD system, known for its reliability in parting off and deep grooving, now offers inserts as small as 1 mm, making it ideal for operations that prioritize material savings. This tool, equipped with internal coolant supply, excels in applications involving low alloy steel. For example, when using a 3 mm insert, optimal cutting data includes a cutting speed, V, of 140 meters per minute, 460 feet per minute, and a feed rate, F, of 0.12 millimeters, reverend, 0.005 inch, rev. The system allows for precise, efficient material removal, making it perfect for tight tolerance machining and reducing waste. The second-generation Coro Turn Prime B inserts by Sandvik Coromant are designed for cost-efficient machining, especially in interrupted turning and challenging materials. These inserts feature double-sided negative inserts with 4 cutting edges, maximizing tool life. A new robust tip seat design enhances stability, even under severe conditions. Updated geometries are optimized for machining tough materials, making these inserts ideal for industries requiring high durability. Torture testing of these inserts highlights their improved wear resistance and performance in difficult cutting environments, ensuring reliable and efficient operation across various applications. The compact master turning and milling spindle, capable of up to 15,000 revolutions per minute and 120 Newton-meters of torque, or 20,000 revolutions per minute as an optional feature, is the core of the CTX Beta 800TC, delivering high performance and precision for complex machining tasks. The machine comes with 2 spindles, left and right, each with a maximum of 5,000 revolutions per minute, 36 kilowatts power, and 720 Newton-meters of torque, making it highly versatile for demanding applications. With a bar capacity of 0.76 or 102 millimeters, it supports machining workpieces up to 0.500 by 1,100 millimeters, all within a compact 10 square meters footprint. Efficiency is a key feature, with the Celos system streamlining the process with app-based workflows, reducing programming time by up to 80%. This efficiency is enhanced by Synumeric 1 technology, which boosts performance and offers new functions. Setup times are minimized thanks to process integration, and energy consumption is reduced by 29% compared to similar machines, achieved through features like braking energy recovery, LED lighting, frequency-controlled pumps, auto shutdown, and sealing air shut-off. The machine also monitors energy use for optimized operations. This 5-axis simultaneous machining platform supports highly complex components with faster processing and greater precision. It allows 6-sided complete machining with the same main spindle and right spindle, offering maximum flexibility in machining strategies. Its process integration goes beyond turning and milling, incorporating grinding with an acoustic emission sensor, gearing, and measurement capabilities. Automation is another strength. With up to 200 tool pockets, 60 as standard. For tools up to 140 x 400 mm, tools can be loaded during production. The workpiece unloading unit ensures impact-free unloading for parts up to 30 kg. Additionally, the integrated gantry loader handles workpieces up to 2 x 15 kg. For small to medium-sized batches, the Robo2Go system provides intuitive automation, reducing labor costs and increasing throughput. The twin drive system in both the X and Y axes minimizes yawing errors and ensures smooth, precise translational motion. This system, coupled with the boxway guides, enhances machine stability and enables precise movement under heavy loads, making it ideal for high-precision machining of difficult materials. The H6 comes equipped with 2 spindle options. Gear-driven spindle offers 8,000 revolutions per minute, 35/20 seconds of a kilowatt power, and 1,654 Newton meters of torque, making it highly suitable for low-speed, high-torque operations. This spindle excels in heavy-duty cutting, allowing for smooth, powerful machining at low speeds. Built-in spindle delivers 12,000 revolutions per minute, 30/25 of a kilowatt power, and 420 Newton meters of torque, suitable for high-speed machining while maintaining precision. Both spindles feature oil jet cooling system, which effectively minimizes thermal displacement during long machining processes. The cooling system helps maintain spindle performance, ensuring stable operation and consistent quality even during extended periods of high-speed cutting. The machine's frame is built for extreme stability. The integral bed frame supports the entire drive system, maintaining high structural integrity. This rigid structure is designed using 3D modeling and finite element method analysis, ensuring thermal stability and maintaining geometric accuracy during long machining operations. The stable design reduces vibrations and allows for superior workpiece quality. The oil jet cooling system, along with jacket cooling, prevents thermal displacement, a common issue during prolonged cutting. This highly effective cooling technology preserves spindle performance, keeping it thermally balanced for consistent high-quality output. The integrated machining software optimizes machine efficiency in real time by monitoring machining conditions and adjusting operational parameters. This ensures the highest quality output and work efficiency, automatically adapting to different work environments for better overall performance. The H6 is designed with user convenience in mind, offering a range of optional features to enhance its functionality. This allows operators to focus on creating high-quality products without concerns about machine failures or safety.